Welcome. In this brief tutorial, I'm going to demonstrate how to conduct a factorial ANOVA using JASP. So in this hypothetical example with some hastily fabricated data, we are looking at the two independent variables. One is attractiveness and the other is argument strength. So we could say attractiveness is, let's say, the attractiveness of a model in an advertisement, and argument strength is the strength of the argument promoting a product in an advertisement, and preference is the participant's indicated preference after being randomly assigned to a condition in this 2x2 design. So attractiveness has two levels, high and low. Argument strength has two levels, high and low. If you combine them, it's a 2x2 design with 4 cells. So one could be in the high condition, one could be in the high-low condition, one could be in the low-high condition, and one could be in the low-low condition. And we're going to compare the means for attractiveness, the means for argument strength, and the interaction of attractiveness and argument strength to see if that affects preference for whatever product. And so to conduct the analysis, we go to ANOVA, and then click on ANOVA again, and enter in the dependent variable, which in this example is preference, and the two independent variables go in the fixed factors box. And it's already run the ANOVA for us, but let's look over some more things first. So the model, we're going to leave this alone. This will test the full factorial model where we have the main effects, all main effects, and interactions. So here there's two main effects, one interaction. We'll leave the type sum of squares as 3, which is usually the default in most programs. It assesses each main effect and interaction sequentially, meaning after the effects of the other effects are taken into account. So we'll leave that alone unless we have a really good reason to change it. There's two assumptions that we will check with the data. One is homogeneity of variance, and the other is normality of residuals or error. We're not going to mess with contrasts for now. We will not need, well, we could conduct post hoc tests, but let's hold off for a minute because we don't even know if we have an effect yet that we need to probe. For descriptive plots, probably a good idea to look at a plot of our IVs and how they might be related to the DV. Under additional options, we definitely want the means. For effect size, I'm going to get the partial eta squared. Could also get omega squared here. And this is a balanced design, so whether we call up the marginal means or the descriptives, it's not going to have an impact on what we interpret. By balanced, I mean we have equal sample sizes in each cell. And for simple main effects, I'm going to hold off on that because we want to make sure that we want to interpret them, because if there's no interaction, it doesn't make sense to look at the simple main effects. So let's go ahead and look at what's in the output. So we see, okay, we have a main effect for attractiveness on preference for the product. The p-value is quite low. That -4, e-4 means move the decimal 4 places to the left. So it's going to be 0.0001 is our p-value. Just by chance, it works out that both of these effects are of equal magnitude. That's really unusual, but that's what I get for hastily fabricating data for demonstration purposes. But we see that the p-values for both of these main effects are quite low, which tells us that there is a difference across the two conditions for attractiveness in the mean level of preference, and there is a difference across the levels of the two levels of argument strength for preference. And the effect size, partial eta squared, is quite large, 0.6. So that's telling us that about 60% of the variance in preference is attractiveness accounts for 60% of the leftover variance in preference after we control for argument strength and the interaction, and argument strength also accounts for 60% of the leftover variance in preference after we account for attractiveness and the interaction accounts for 44% in preference after we account for attractiveness and argument strength. And also the interaction is statistically significant with a p-value of 0.002 and a reasonably large effect size. So we're going to need to, we don't have to conduct post hoc tests on attractiveness and argument strength because they both have only 2 levels. So if there's an effect, we can look at the means and be able to determine the effect. For attractiveness and argument strength, we're going to want to probe that, but let's hold off and check the assumptions. The p-value for the test for equality of variance or homogeneity of variance is 0.28, which is high. We want that p-value to actually be high because if that's lower, it means that we violated that assumption. For now, we're going to assume that we have not violated that assumption, although I should note that the sample size is quite small, so it would be tough for this p-value to show up as statistically significant. Here we have a plot where the line represents the quantiles of the normal distribution. So if the data are normal, they will fall along this line. So if it was perfectly normal, or I should say the errors, if they were normal, they would fall along this line. If they were perfectly normal, here we do have some deviations from the line. I don't think there's anything to really be terribly concerned about. They seem to deviate a bit here and there. It would be nice to look at the histogram of residuals, but that's not an option in JASP at this time. All right, here we have just comparing the cell means. So we see the mean for high is 7.2. The mean for high attractiveness, low argument strength is 6.6. The mean for low attractiveness, high argument strength is also 6.6. And the mean for low is 2.8. So we can see that the low condition seems to deviate a lot from the others. So if we look at this line graph here, it gives us an idea of where the differences are. So the high argument strength condition doesn't really show a difference between high and low attractiveness. So attractiveness seems not to matter when the argument is strong, but when the argument is weak, we see that attractiveness does have an effect. Specifically, the low condition, the mean is considerably lower than the other conditions. So we're going to request a statistical test of these main effects, basically of these lines. So I'm going to go into simple main effects. So JASP makes this pretty straightforward. So our focal variable, it's kind of arbitrary at this point, but we'll make our focal variable for now attractiveness, and we'll make our moderator argument strength. And now we'll find where that table shows up. Here it is. So we see that among participants who were assigned to the high argument strength condition, the effect of attractiveness is not statistically significant. So when the argument strength is high, attractiveness doesn't seem to matter. When the argument strength is low, however, we see that attractiveness has a huge effect. So looking at the means, can see that the low condition is what seems to drive this interaction. So another way we can decompose this interaction, simple effects analysis is probably the best way. And we could look at it the other way as well. We could look at, let's go ahead and look at it the other way. We could look at the effect of argument strength within the attractiveness moderator. So here's that table. So we have now argument strength up here, and we see that for high attractiveness, argument strength doesn't matter, but for low attractiveness, argument strength does matter. So we've just kind of switched out the focal independent variable and the moderator. So in this example, it's arbitrary, but if you have a theoretically proposed moderator, you would probably want to treat that as the moderator and enter the focal independent variable as such. And one other thing we could take a peek at is we could conduct a post hoc test, and we could look at all the cells if we want to kind of go fishing to see where the difference is. I think we have a pretty good idea already, but this will allow us to apply an error correction. So we'll go with the 2-key error correction. We can ask for the effect size, and while we're at it, it's free. Let's ask for the confidence intervals. And let me identify that table. Here it is. So we're comparing basically all the cells. So high, and low, so attractiveness is on the left, and argument strength is on the right. And we can see, okay, is high and low, is there a difference? No. Is there a difference between high and high low? No. But we see that high and low have a difference, right? The p-value, the corrected p-value using the 2-key post hoc correction is considerably low. And also comparing high-low to low-low, we see that that difference is significant, and also low-high to low-low is significant. So basically it tells us, it gives us a significance test for what we've already seen in the graph. So to summarize the findings here, we can say that there was a main effect of attractiveness such that higher levels of attractiveness led to more preference for the product as compared to lower levels of attractiveness. We could say there was a main effect for argument strength such that stronger arguments led to more preference for the product than weaker arguments. But perhaps most interestingly, there was an interaction such that the effect of argument on preference for the product was contingent on the level of attractiveness. So argument strength mattered most, or had the stronger effect, when attractiveness was low, and argument strength did not have an effect when attractiveness was high. All right, I thank you for watching this tutorial. I hope that it helps you conduct your very own Factorial ANOVA. And thank you, and have a good one.